So, the retrieving force would basically be the force working on bringing our universe back to the state it started with. It would operate in a different way from gravity, that's for sure. You could consider it as a kind of mother force for both gravity and dark energy. Now let's talk about the potential properties of this R force. One of the potential functions of the retrieving force could be the decay of subatomic particles into another subatomic particle. It's like a phase transition to another state, in an attempt to be retrieved to its original state. During the retrieving process, the particle or wave will undergo partial retrieving phases. These could be referred to as partial retrieval or phase retrieval, in forms of decay or changing states. During each of these retrieving phases, the particle or wave will gain information or experience. This new information would affect its next phase or its reconstruction. The conditions or states in which the retrieved particle or wave ends up with, or during the retrieving phases, won't always necessarily be the same exact initial states or conditions. It's kind of fascinating, isn't it? So here's something fascinating. The retrieving force could potentially have the ability to transform time into space and, well, vice versa. Imagine that. It could create and annihilate spaces by acting on or using creation and annihilation operators. Quite a mind-bending concept, isn't it? Now, let's delve a bit deeper. The retrieving force would operate on a particle that exists beyond the usual space and time boundaries, with what we call a unified space-time operator. I know, it sounds pretty counterintuitive, right? But don't worry, we'll use some analogies to try and make sense of this idea. And, to take it a step further, the retrieving force would be in the realm of creating and annihilating space and time itself. It's like a dance of existence and non-existence, all tied to the fabric of our universe. Mind-blowing, isn't it? Gravity and dark energy could be tools for the R-force to retrieve the ISWs and matter to their original state. The R-force could be responsible for the antimatter using annihilation operators to annihilate matter. We want to examine how our imaginary R-force could operate on the muon, for example, given the above-mentioned properties. But before we start, what is a particle in the first place? What is a particle? In the late 19th century, and with the discovery of the electron, we knew that they are negatively charged particles. This was based on the work of the scientists during the 1880s and 90s, when they searched cathode rays for the carrier of the electrical properties in matter. Their work culminated in the discovery of the electron in 1897 by the physicist J.J. Thomson. It only took us less than 3 decades to discover the electron-possessed spin. With progress being made in physics generally and quantum mechanics specifically, our understanding of particles, including electrons, started developing. If you ask a group of particle physicists what a particle is, you might get different answers on the definition of the particle. One of the interesting definitions is that a particle is a collapsed wave function. The wave function representing an electron, say, is spatially spread out so that the electron has possible locations rather than a definite one. But when you measure the electron's location using a detector, its wave function collapses to a point, and the particle clicks at that position in the detector. Making a measurement is establishing an entanglement between the detector or device and a system. Another interesting definition of the particle would be, a particle is a quantum excitation of a field. Quantum field theory is the math where particle physics is written, in that there are a bunch of different fields. Each field has different properties and excitations, and they are different depending on the properties. And those excitations we can think of as a particle. As physicists discovered more of nature's particles and their associated fields, a parallel perspective developed. The properties of these particles and fields appeared to follow numerical patterns. By extending these patterns, physicists were able to predict the existence of more particles. Once you encode the patterns you observe into the mathematics is predictive. It tells you more things you might observe. Explained Helen Quinn, emeritus particle physicist at Stanford University. The patterns also suggested a more abstract and potentially deeper perspective on what particles actually are. What we think of as elementary particles, instead they might be vibrating strings. Mary Gaillard. Physicists are trying to fit symmetries inside a single, larger group of transformations. The idea is that particles were representations of a single symmetry group at the beginning of the universe. Researchers placed high hopes in string theory. The idea that if you zoomed in enough on particles, you would see not points but one-dimensional vibrating strings. You would also see 6 extra spatial dimensions, which string theory says are curled up at every point in our familiar 4-dimensional space-time fabric. The small dimensions geometry determines the properties of strings and thus, the macroscopic world. Internal symmetries of particles like the SU3 operations that transform quarks' color obtain physical meaning. These operations map, in the string picture, onto rotations in the small spatial dimensions, just as spin reflects rotations in the large dimensions. Geometry gives you symmetry, gives you particles, and all of this goes together, Nanopoulos said. The theoretical physicist David Tong explained that there are fields that underlie everything, and what we think of as particles are not really particles at all. They are waves of these fields tied up into little bundles of energy. There are no particles in the world. Our universe's basic fundamental building blocks are these fluid-like substances that we call fields. The spin of massless particles is a bit different in some ways than the spin of massive particles. The basic difference is that massless particles can never be brought to rest. They move with the speed of light. Even if you try to slow them down, they still move with the speed of light. Whereas particles with mass, you can slow them down and bring them to rest, and that makes the difference in certain properties about spin. The sleeping muon analogy. Let's consider Alice as a muon. She will decay from Alice Moon to Alice Electron in about 80 years. The question is, during these 80 years, is there anything beyond the space and time Alice is recognizing affecting her, something that she can observe? Does not control during her sleep. But is that different space and time that we cannot scientifically explain yet affecting the massive Alice in our world within the boundaries of space and time of our world? The answer is, we do not really know. There are chances that what Alice is experiencing in this different space and time affects her on a very fundamental and subtle level that we do not really understand or are not yet able to track and measure. Maybe we cannot yet measure its effect on Alice, but we have better chances of measuring it on an actual muon. This would be the retrieving force acting on the muon. The retrieving force would be operating on the muon with space and time of different properties, causing minor effects in the initial state of the muon that would probably trigger further changes leading to phase transitions in a butterfly effect manner. The analogy might not be the most accurate description. It is not suggesting that dreams are a retrieving force operating on Alice. But it is just an attempt to clarify the probability of a force that is different from gravity acting on the muon with different space and time properties and parameters. Another inevitable question would come up. Is the retrieving force the only force beyond our space and time operation on Alice or our moon? The analogies used in the book, The Big Defreeze of the Universe, suggest that there are two more forces beyond space and time that could be acting on Alice or the muon. These would be the balancing force and the higher dimension force. Both would qualify as separate imaginary complex forces as they have different properties and functions.